let's look at another problem which basically says that find the first and last occurrences of the given elements. So here ultimately what is going to happen, we will be given an array of integers in the variable nums which are sorted in ascending order. Remember that these constraints are very important. Values are sorted in ascending order. We need to find the start and end positions of a given target value. So along with this nums array, we will also be given the target value. Ultimately, we need to find in those sorted array of values which are sorted in the ascending order, we need to find if this target value is available, and it could be available multiple number of times also, right? So ultimately we need to find at what index it is occurring first and at what index it is occurring last. So we need to find the first and last index. So here look at this example, right? Here the values we have gotten are 5, 7, 7, 8, 8 and 10, and the target that we are looking for is 8, right? So indexes, if we give 0, 1, 2, 3, 4, 5. So starting index is 3 and ending index is nothing but, last index is nothing but 4. So the output is 3 and 4. Okay, so in the end we need to return two values, either it could be list or an array which has only two values. Ultimately the first value should be having the first starting index and the second value should be ending index at which the value is occurring last time. Okay, so here we got the same array of values. So indexes 0, 1, 2, 3, 4, 5 only, but the target value is 6. So there is no 6 in the given array of values, right? So it is not at all occurring. So in this case, we need to return -1 and -1. Okay, so these are the two examples. Let's just say if we have been given the same array and the target value is 5, in that case 5 is occurring first time at index 0 and last time also it is occurring at index 0. So we need to return 0, 0 itself. And the other scenario here we have gotten is an empty array and the target we are looking for is 0. Obviously empty array we don't have any values, right? Immediately we will need to return -1 and -1. Okay, so that is the problem statement that we have gotten. Here we have gotten few constraints in terms of what are the maximum number of values we can have, and at every index what is the maximum value we can have. Those are the couple of constraints that we have gotten. Ultimately we need to solve this problem in the effective way. Now let's look at the brute force approach for solving this specific problem for finding the first and last occurrences. Here let's just assume that we have taken one of the example which has the values 1, 2, 3, 4, 5, 5, 5. Here if you see all the values are sorted in the ascending order, and let's just assume that the target value that we are looking for is, let's just say 5. So in the case of brute force approach, what we need to do, we need the first occurrence and last occurrence, right? So we can write a function in which we can have one variable called first occurrence, we can initialize it with -1, and we can have another variable last occurrence. This also we can initialize it with -1. Immediately what we can do, we can run a loop starting from 0th index till the very last index, which is nothing but length of the array or nums array, whatever the variable that you have gotten. Inside this loop what we will do, whenever this first occurrence is -1, that means that we still not have found the first occurrence, right? Let's just say here, if at all the value at ith index is equal to the target value that we have gotten, then we found the particular value. And here once we have the first index value, then only we can go for the last index value and update it with the appropriate value, right? So immediately what we can do, you can put another check. If at all first occurrence index is equal to -1, immediately first occurrence index equal to I. If this is not the case, that means that first occurrence index is having some proper index value. That means it is later occurrences. That means that index need to be updated into the last occurrences. So last occurrence equal to I. Okay, so this is what we will be doing. If at all the index value is not going to match, we will not do anything. We will simply move on to the next values. So once this logic is done, we have the first occurrence index and last occurrence index in these two variables. What we can do, we can put them inside an array or list and we can return that specific value. Very simple one. Iterate over each and every value at any index. If the value is matching with the given target value, based on the two variables that we have, compare them based on the values availability, update the appropriate value for keeping track of the indexes of first occurrence or last occurrence. Okay, now let's try to understand the time complexity involved in this specific implementation, right? So obviously we are iterating over 0 till the length of the array. That means that this entire range we are iterating over. So if there are n number of values, obviously this is going to take n units of time. As a result, the time complexity can be order of n. Okay, so that is the understanding. And obviously the space complexity is, here we have only two variables, and these two variables are simple integers and they are going to consume constant, right? So the space complexity is nothing but order of 1. Okay, now order of n in the case of a sorted array is very bad. So is there any way using some technique which we can find the first occurrence and last occurrence effectively by bringing down this order of n to somewhat lower time complexities? So that is where, since the array is sorted, we can apply the binary searching technique. Okay, all right, now let's look at how can we apply the binary searching technique on this problem and find the first and last occurrences of the given target value effectively in. Obviously if you are applying binary searching technique, it will bring down the time complexity from order of n to order of log n, right? So we will see what exactly we will do. So whenever we so one thing that you have to understand here is, we will apply binary searching technique twice, once for finding the first occurrence, and second time again we will reinitialize the variables, and again we will apply the binary searching technique for finding the last occurrence index as well. So 2 times binary searching technique we will be applying. So that is what you need to remember here. So how exactly we will do? Let's just apply the binary searching technique for finding the first occurrence first. So we will define variables pointing to start and end. Start will be pointing to index 0, end will be pointing to the last index. Now we have a range in which we need to search for this target value. So immediately what we will do, we will calculate the middle. So middle is nothing but 0 plus 6 divided by 2, which is nothing but 3. So this is where we have gotten the middle index. Now immediately what we will do, we will check if this middle index value is equal to the target. So here, is our middle index value is equal to target? No. That means the target value could be either on the left side or on the right side. Remember that here the value has not matched at the middle index with the given target value. So it could be there on the left side or right side based on the value's nature. So here the value we have is 4, right? 4 is smaller than the target value. That means that 4 could be anywhere after this index. So immediately what we will do is, we will update the start with the middle plus 1th index. Now the search range will be from 4 to 6. Again we will calculate the middle. So middle is nothing but 4 plus 6 divided by 2, which is nothing but 10 by 2, which is nothing but 5. So here we have gotten the middle index to index 5. At index 5, what is the value we have? 5. So we have found the target value. But remember that here we are applying this first time binary searching technique for finding the first occurrence. At index 5 we have the 5 only. But we can't definitely say this 5 is the first time occurrence. This could be first time or this could be the last time. But if at all, if it is the first time, then there should be no values on the left of it. So here at index 5 we have the 5. There could be still 5s on the left of this 5. That is the reason why there is still a chance that 5 could be there before this middle index itself. That is the reason why here what we will do is, end we will be updating it with the middle minus 1. So right now both start and end are at the same index. So what we will do, we will again calculate the middle. So 4 plus 4 divided by 2, which is nothing but 4. Middle also we have gotten the same index. At index 4 what we have? We have 5 again. So again we found 5. So in that case what we will do, previously at the first occurrence index one variable that we define, we will store 5. But now this 5 should be overridden with 4. Okay, so index 4 is done. Now what we will do, there is still a chance that on the left of it there could be another 5, which is the first occurrence, right? So immediately end we will update with the middle minus 1. Now start is at index 4, end is at index 3. So we can't compare, right? Start has become greater than end, so we no longer need to compare. So here the first occurrence is there at index 4. So once we have ran the logic for all the values till start is less than or equal to end, we have found the first occurrence. Now we need to find the same, apply the same logic and find the last occurrence. So for that, again, start we will be initializing with 0 and end we will be initializing with the last value. Again we will calculate the middle. So here we will start calculating the middle. 0 plus 6 divided by 2, which is nothing but 3. At index 3 we have gotten the middle. So here 3 is middle, right? So at index 3 we have 4, but we want the target 5. So 5 is greater than 4, right? So what we will do, immediately we will update the start to index 4 and end will be at index 6. Again we will calculate the middle. So 4 plus 6 divided by 2, which is 5. So here 5 is the middle. Okay, at index 5 we have value 5, right? We have value 5. But remember that here this 5 could be the last occurrence. But if there are any values on the right, there is still a possibility that 5 could be there. But in the case of finding the first occurrences, we have moved to the left because first occurrence will be there on the left side. Since here finding the last occurrence will be on the right side. So what exactly we will do is, start we will update with the middle plus 1. Right now it will be 6. So both start and end are at the same index. Again we will calculate the middle. So 6 plus 6 divided by 2, which is nothing but 6 again. At array index 6, previously whatever the value that was matching, we will store it in last occurrence index variable, which is nothing but 5. And now again middle that we have gotten is 6, right? So here middle is pointing to the same. At index 6 also we have the 5. So this could be the last occurrence. So immediately what we will do, we will update the last occurrence with this middle. And then again, if there could be another 5 on the right? So immediately we will update the start to middle plus 1, which will become 7. Now obviously here, it is an invalid condition, right? So we don't need to run this logic anymore. And the first occurrence and last occurrence are there inside the individual variables. First occurrence is at index 4 and last occurrence is at index 6. Okay, so that is the way of finding the first and last occurrence using the binary searching technique. So apply binary searching twice, once for finding the first occurrence and once for finding the last occurrence. Okay, now let's quickly dive into the pseudo code for this specific problem. So what we will do, we will define one function called find first occurrence and last occurrence, and what it does, it will take the nums array and it will take the given target value as well. So immediately what we will do, we will define one variable called first occurrence, initialize it with -1, last occurrence, initialize it with -1, and since we are going to apply binary searching technique, initialize the variables start, end will be length of the nums -1. Now binary searching technique twice, right? So here, as long as this while start is less than or equal to end, what we will do, we will calculate the middle is nothing but start plus end divided by 2. Now immediately we will compare. If the nums array of middle is equal to the target, then we found the value. In that case, what we will need to do, since we are applying binary searching technique here for finding the first occurrence, we will update the first occurrence with the middle index, and there is still a chance that there is another same target value on the left side. Like I mentioned, at index 5 we had the 5, but there is still a chance that at index 4 there can be another 5, right? That is the reason why here we will update the end with the, whatever the middle minus 1. If this is not the case, there are two other scenarios, right? If at all the nums of middle index is greater than whatever the target that we have gotten, in that case what can happen, whatever the let me move this logic here, else if whatever the nums of mid is greater than whatever the target that we are looking for, the middle index value is having greater value than whatever the target value that we are looking for. That means that we need to find for the smaller target. That is the reason why here we will update with the end with the middle minus 1. If this is not the case, we want the greater value. Greater values are there after the middle. So we will update the start with middle plus 1. Okay. Once this while loop is done, we will have the proper first occurrence index inside the first occurrence variable. Similarly, we will need to write the same logic for the last occurrence also, but here instead of updating the first occurrence variable, we will update the last occurrence. And here once the value is found, since we are finding the last occurrence will be there on the right part. So here instead of updating the end, we will update the start to middle plus 1. So that is the only change that we have to do to get the last occurrence index as well. In the end, we will need to return the values we have inside the first occurrence and last occurrence. If at all the value of the target is not found, anyway we are defining it with minus 1 and minus 1, right? So we will be returning minus 1 and minus 1, which is perfectly fine. Okay, so that is the effective way of finding the first and last occurrences indexes using the binary searching technique. Now here let's quickly analyze the time complexity, right? So here we are running a loop. This will take order of log n units of time. Similarly, for finding the last occurrence also, we will run the same loop. It will also take order of log n units of time. So it will be order of log n plus order of log n. So it will be 2 into order of log n, which is nothing but log n itself. And the space complexity is nothing but we are defining only 4 or 5 variables, and these variables are going to consume constant amount of memory. As a result, the space complexity will be order of 1. Okay, so that is the effective way of finding the first and last occurrence index in a given array of values for the given target using binary searching technique. Okay, now that we have seen and written the pseudocode also, let's quickly jump into the implementation and validate it on the various scenarios.